blockchain is not there to disrupt something. Blockchain is not there to kill someone or to kill a certain industry or something like that. What I think, blockchain is going to be an integral part or integral component of every business out there, right?
Hello and welcome everyone. Hope you are keeping well and staying safe. This is Hafsanjum and I am working as a community executive at Recro, wherein we are working towards building an exclusive community for developers to help you get connected with like-minded people, build your network and grow professionally. So those who don't know about what Recro is, we are a developer-focused platform helping developers to meet the right opportunity by connecting them with fast-growing startups such as CureFit, Udaan, Swiggy, Dunzo, etc. And today we are doing a webinar on basics of blockchain. Our guest speaker for today is Sameep Singhania. He's a co-founder of Genet Technologies. He has been professional programmer for the past 6 years. Sameep is a blockchain enthusiast who helps teams adapt their use cases of blockchain technologies. Recently, Sameep has been focusing his energy towards the blockchain technologies to devise strategies for businesses clients to adopt blockchain technology to solve transparency. Thank you so much, Sameep, for joining us. You can go ahead and say hi to the audience.
Hey, thanks, Hafsa. Thanks, Recro, for having me here. I just would like to correct you. I'm not a professional programmer for 6 years. It's like 10 years now. And yeah, thanks for having me here. And guys, I would love to have some interaction with you. Talk more about what blockchain technology is. And how it's going to change the world and like what it means to basically use a blockchain technology for everyone out there. It's a very important technology, actually.
So before we start, Sameep, I have some announcements to make, and then we can go ahead with the presentation. So for those of you who are joining us, you can post your questions in the Q&A section. We will take them up parallelly to the session, or if you want, we can also take them up at the end of the 15 minutes of the session. And we will be rolling out polls in between, so make sure that you answer them and keep your notepad handy so that you don't miss out on any key takeaways from the session today from Sameep. And you can post it on LinkedIn, you can post it on your Twitter or any social channels. You can tag Sameep, Recro, and me, and then we'll be good to go. Yeah, over to you, Sameep. I think we can get started with the presentation.
So I basically, created this small presentation, for anyone who wants to understand what blockchain is all about and why it's a revolution, right? So, like if you see into this particular slide, I've written blockchain revolution, internet of value, right? So internet, it's a very broad term, and the way we are using internet right now, like it's not internet of value, it's I would say it's internet of data or internet of information. Because using internet right now, we do not share value, we share information, right? All the value is actually stored in banks or in a physical records. Even if you have money, it's stored in banks, right? Now someone can say I can do some kind of online transactions, but those online transactions are also actually facilitating a physical asset transfer, right? INR, it's actually a physical asset. Through online transaction, IMPS, NEFT, you're not doing a transfer of value, you are just doing a transfer of information, which basically says I'm transferring my physical asset to someone else, right? So the way we use internet right now, it's more of a value or not value, sorry, data or information. And what blockchain enables is it's enable internet to be an internet of value, right? It puts value onto the internet where we can actually do asset transfers, value transfers on, on internet, or I would say on any kind of networks. Internet is just one of them. So let's start and like see what blockchain is all about. I'm going to start from the very beginning, right? Okay, so just to like give you an idea, what blockchain is all about, why this technology is very important. So I'm not sure how many of you know about Gartner. Like Gartner is one of the biggest organizations in the across the globe who basically ranks different technologies at which particular stage a certain technology is, a certain company is, right? And this is a Gartner cycle, basically. It's a very famous cycle. This I think this particular graph here, it's a bit old. I think it's 2018 or 2019 graph, but it's still, if you look into it, blockchain. Okay, so first of all, blockchain is a very new technology. The idea of blockchain came into existence in 2008, and the blockchain and the Bitcoin being the first blockchain out there, it's actually started in 2009, January of 2009, right? So it's still fairly very new, I would say. We are sitting in 2022. So how many years since 2009? It's almost 13 years, right? So 13 years is not a very long period for certain technology, I would say. There are certain technologies out there like, quantum computing. People have been talking about for 20 years now. For IoT platforms, people have been talking about for more than 15 years. Neural networks, I think for 20, 25 years, artificial intelligence and everything. So, but if you look into this particular graph, you'll figure out blockchain, though it's a new technology, but it's still far ahead from other technologies out there, which is already being talked for ages now, like 5G, quantum computing, AI, smart robots, smart workspaces, digital twin block chips, and everything, right? We have been hearing all these terms in one way or another since last 15, 20 years. Blockchain being is still being very new, it's far ahead from these technologies, right? Which means like blockchain has some real use case, and the overall technological advancement happening in blockchain is much faster than other platforms out there, right? AR, VR, everything is behind blockchain right now, right? So let's move ahead now. What blockchain is all about, So basically, blockchain, it all started in 2008. I think most of us already know that, in the form of Bitcoin. I think most of us must have heard about Bitcoin, right? So blockchain actually started with Bitcoin. So it was nothing. It was just a paper, like white paper, I would say, from Satoshi Nakamoto, which basically outlined a new system, a new way of transacting across people, across two parties, without need of any centralized governance or without any need of third party, right? So when you transact with someone, let's assume I'm transacting with Hafsa, right? And when I can, there are multiple of ways of doing it. I can either go to Hafsa, hand over her some money, right, and then get her services, or I can go to a bank, right? So in this case, bank is a third party. So when you do a transaction to someone else through bank, actually you're not transacting to that person, you are transacting to a bank. So what do? You basically give your money to the bank, and then bank, acting as a centralized authority, give that money to someone else, to the other person, third party that you want to pay, right? And now in future, if some conflicts happen, something happen, you can go to the bank and say, this these kind of activities have happened and I want a refund, or you can go to the courts and put some claims out there. So in this case, you need a third party. In entire transaction system or financial system, if you look, there is an involvement of third party for transaction between two-person. It's not truly peer-to-peer, right? I cannot simply have a transaction with someone I don't know without having a third party, because I need a third party for to safeguard my funds so that I'm not, I'm not scammed or something. But Bitcoin enabled that particular technology where I can have a true peer-to-peer transaction. I can send Hafsa some Bitcoins without need of someone verifying it, without any need of centralized authority. So that's what all blockchain is all about, right? A system for electronic transactions without relying on trust. So I do not have to trust anyone to transfer my funds to someone whom I don't know. So this was the problem. The trust was the problem in the centralized entities, which basically led to the 2008 recession. Right, that was the trust. That was a centralized entity failure. One of the biggest banks, biggest lenders in the world failed, Lehman Brothers, and that basically resulted in the entire global recession, like people losing their jobs, suicides, and everything. Like, I mean, disasters was happening at that time, just because one of the biggest trusted entity, they got bankrupt. So Satoshi basically wanted to remove this trust, because this trust, it has a very high value in the future. You might trust someone today, but what happens in 20 years if that trustable person or that trusted entity, they went rogue, or they went bankrupt, or they they do something against you, right? So the trust was a very big thing, and Satoshi wanted this trust not to be just with one particular person or one particular entity. It should be entrusted into the entire network. Actually, that's what he visioned. So that's what Bitcoin is all about. In Bitcoin, you do not trust one single entity, but you trust the entire network. So somehow the entire network goes rogue, every participant in the network goes rogue, then the Bitcoin is finished. That's how it works, right? So trust is not in a single entity or single party or single organization. It's actually within the entire network. That's how it works. So that was blockchain. That was Bitcoin, right? That was like peer-to-peer transactions, where you don't trust one person, you trust the entire network, right? So now what is blockchain? So if you talk about a very, I would say a definition, or a legal definition, I would say, or a very legit definition, the blockchain is an incorruptible digital ledger of economic transaction that can be programmed to record not just financial transaction, but virtually anything of value. Now, I know this is hard to understand, right? Now, let's try to understand from a different perspective, right? So if you look at the word in itself, blockchain, right? That basically tells you everything about what blockchain is all about, right? So it's chain of blocks, right? And that what makes blockchain, chain of blocks. Now what is a block? Now that's an important question. What is a block? That's the important stuff out there. I think most of us must have seen or must be using it. We might be using it as well. But as far as I remember, my father used to have uh, in his business that physical ledgers, I would say, or we call it bahi khata in Hindi. I'm not sure how many of you know about it. That those physical ledgers and stuff, that red color book, long red color books where our father used to, or our like businesses used to make the entries before all these laptops and everything came into existence, right? When there used to happen a physical records, right? So what used to happen in those ledgers, right? Whenever I am doing some transaction with someone, let's assume uh, I am doing, let's say, some kind of entity selling business, some kind of wood selling business. Let's assume I'm selling bananas, right? For just for an example. So whenever I do some kind of trade with some other person, I used to make an entry in that particular physical ledger that, let's say, I sold 100 bananas to AB to XYZ person at the rate of, let's say, 45 rupees, 45 INR, right? And that same person might be making entries into his ledger as well, that I bought 100 bananas from Sameep Singhania at the rate of this much amount, 45 rupees, right? And this is how we used to make entries into that physical ledger. And the other party also used to make all the entries. That was, I think, the first form of blockchain, right? If you'll ask me. So in that particular ledger, there used to be multiple pages out there. When the first page is finished, you used to go to the next page and make same entries like credit and debit. Bought something from someone, sold something to someone. Bought something with someone, sold something to someone. That's how that particular ledger used to work. And now if I have, let's for an example, if I have sold something to someone, but I never intended to do that, or I made a wrong into the ledger. So what used to happen, I have to make another entry to cancel that particular entry, right? I cannot simply cut it off, because if I cut it off, I can see it in the ledger that something has been cut off. So let's assume I made an entry that I sold 100 banana to XYZ person, but that's a wrong entry. So I'll make another entry where I'll say I got a cashback, or I got my 100 bananas back from XYZ person, right? So that's how it used to work. You cannot cut it, because if you will cut it, everybody can see, or someone who is verifying your ledger entries will see that something has been cut from this particular ledger, right? So now, if I'll compare it with the blockchain is that ledger, uh, the digital version of that ledger, right? And what is a block? I would say block is a page. If you compare it from a page, because what page was nothing but a collection of transactions that we used to make in a business, that we used to do in a business. Similarly, in a blockchain, a block is collection of transactions. Like in case of Bitcoin, it's collection of Bitcoin transactions, where if XYZ person made some transfer to some to ABC person for a certain Bitcoin, let's say 100 Bitcoins, that entry will be made into a block, right? And when a block is finished, like in a ledger, page had some capacity. Let's assume it can only take 100 transactions. If you have to write 101 transaction, you have to turn on the page and move on to the next page. Similarly, in blockchain, a block has a capacity, right? That it can only handle, let's say, 100 transactions. So 101 transaction will be put into the next block, right? Same. I mean, like, I'm just trying to make it easier for you guys. That's why that particular example, right? So that this is all blockchain is. Blockchain is nothing else. It's simply a digital version of that physical ledger. The biggest difference between that physical ledger and this digital ledger is, in case of physical ledger, everybody used to maintain their own book, their own version of physical ledger. I will be having my version, Hafsa will be having her version, Rashmi will be having her version, somebody else will be having their version. Now, if let's assume I made a wrong entry in my ledger, and now somebody comes up and claim, no, this is a wrong entry, we never made this trade. Now, how do we verify? Right? There was no way of verifying this. So in case of blockchain, we just have one global ledger. Everybody is making their entry over there. Now anybody can verify whether that entry is correct or not. And that verification process is basically done by the entire set of networks or entire set of miners. We'll talk about miners later on. But I would say the network participants. So blockchain is nothing, just one global version of that physical ledger put onto the digital version. That's what blockchain is all about. Now, and what is a block? Nothing. Block is just a page, right, which contains list of transactions. And when that particular page is full, we move on to the next page, move to the next block. and every block is associated with its previous block. Like in case of page, if you'll tear, let's assume if you go to a ledger and if you want to tear a certain page, if you'll tear that particular page, now again, if somebody is verifying your ledger, that person will get to know that something has been torn off from this particular ledger, a page is missing, right? Similarly, the way blocks are intertwined with each other, or they are mixed up with each other, or they are connected with each other, that if you try to pull a block out of a blockchain, everybody will get to know that a block has been pulled out. That's why blockchain is secure, right? Because if you try to erase a transaction from the blockchain, it's not possible. Like physical ledger, it's not possible. If you try to delete the entire set of, let's say, 100 transactions, it's not possible. You cannot remove a block, like you cannot remove a page. You can do that, but everybody will get to know that, yeah, something has been removed, right? So that is what blockchain is all about, I would say. Now let's move ahead. Now, if you want to understand it more, it's immutable. You cannot delete anything from the ledger, as I explained. You cannot delete it. If you will try to delete it, people will know, that network will get to know, and network will reject your deletion. They will say, no, it's illegitimate, it's not legitimate, we are not going to accept it into our blockchain, into our version of blockchain, which is like global version. Appendable, can add to a ledger, exactly like a physical ledger. You can add more transactions, right? You can add more pages. Similarly, in here you can add more transactions and more blocks. So in physical ledger, you cannot add more pages, right? There's a limitation on number of pages, but on blockchain, you do not have any limitation on number of blocks, right? One block is finished, next block, next block, next block, next block, and it can go to infinite number of blocks. It's universally distributed. As I explained this, the difference between a physical ledger and the blockchain is it's universally distributed, or it's a global ledger, I would say, right? Everybody having the same copy of the ledger, one big ledger out there. Not my personal copy, your personal copy, someone else's personal copy. No. Open ledger. Again, it's an open ledger. In case of physical ledger, there used to be a closed ledger. My father must be maintaining his ledger and he might not share it with someone else, right? I do not want to show my transactions or stuff to everyone out there. But in case of blockchain, we'll talk about private blockchains at later stages, but generally speaking, it's an open ledger. And here we are talking about public blockchains, not private blockchains, okay? No need for centralized authority to validate transactions and hence called peer-to-peer trustless mechanism. Now, as I said, I'll explain this later as well, but for now, just take my word. Like in case of blockchain, if you are doing some transaction, you don't need any third party or centralized authority to validate that transaction. So let's assume if I'm saying I'm going to transfer 100 Bitcoin to Hafsa, right? Nobody needs to verify whether I own those 100 Bitcoins or not, right? But what I can actually do is, let's assume I'm a wrong party. What I can do, let's assume I have 100 Bitcoins. I can transfer 100 Bitcoins to Hafsa and I can transfer those same 100 Bitcoins to someone else as well, right? Now, since there is no centralized authority verifying or no one verifying that I actually own those 100 Bitcoins, who is going to do that verification? Now, that's the next question, right? If there is no one to verify to validate a transaction. So like, as I said before, that validation is done by a network, right? It's my job to send a transaction. Even if I don't have money, I can send a transaction, right? Let's assume I don't have 100 Bitcoin. I can send a transaction saying I have 100 Bitcoin, transfer it to Hafsa. Now it's the responsibility of the network to somehow verify. We will see how that happens and come to a consensus that Sami doesn't own this 100 Bitcoins. This transaction is illegitimate transaction, fail this transaction, and the transaction will be failed. Now, if I own those 100 Bitcoins, the transaction will be successful and the balance will be reduced from my account and will be transferred to Hafsa's account or someone else's account who I want to transfer this money, right? So blockchain, again, like it has many meanings, like it has many definitions, but the core thing is it's just a collection of blocks which are interrelated to each other and it cannot be changed over a period of time. Like that's the important thing to understand. And another thing is it facilitates true peer-to-peer transactions without need of any centralized entity. It is still needs someone to verify. If somebody says blockchain doesn't need any verification, that's wrong. Even in case of blockchain, verification happens, right? If verification is not happening, how do you prevent double spends? How do you ensure someone actually owns some money? So verification happens on blockchain. It's just that verification is not done by a centralized entity. That verification is done by the network itself, right? So to understand power of blockchain system and this is very important, right? And a lot of people confuse this. So I would like everybody to read this, right? To understand the power of blockchain systems and the things they can do, it is important to distinguish between three things. This is very important, that are commonly muddled up or mixed up, namely the Bitcoin currency, the specific blockchain that underpins it, and the idea of blockchains in general. right? So now there are three different things, I would say. The idea at the top level is the idea of a blockchain in general, which I just explained. Now different blockchains can implement that particular idea in a different ways, and they can use it in different ways. Like if I'll give you an example, so there is a cloud technology, right? So cloud technology is an idea where everybody who wants to host something doesn't need the physical servers, right? They can, participate in the shared servers or stuff. That was the idea, like the general idea behind the cloud service or cloud computing. Now multiple applications out there, multiple providers out there have their own specific implementation of that idea, right? Nobody owns that idea, right? But AWS owns AWS is basically one of the specific implementation of how cloud computing should happen or should be done. Similarly with Azure is another implementation of cloud computing. Google Cloud Platforms is another implementation of cloud computing. IBM having its own implementation, Digital Ocean having its own implementation, right? And like hundreds of people out there having their own cloud computing, implementation. Similarly, in case of blockchain is an idea that's how transactions should happen. That's how assets should be managed. Like this is how blockchain should work. Now there are multiple blockchains out there who have their own implementations. Like Ethereum has its own implementation, Bitcoin has its own Ethereum implementation, EOS has its own implementation, Polygon has its own implementation, BSC has its own implementation, Avalanche, Phantom. I mean, like a lot of blockchains out there. I just cannot name everything over here. Now, the third thing is the applications built on top of blockchain, right? And that is what Bitcoin is all about. So Bitcoin basically, when you talk about blockchain, people confuse it with Bitcoin. They think that Bitcoin is the blockchain, right? But Bitcoin, I would not say it is a blockchain. Bitcoin is like one of the first implementations of blockchain, one of the first applications of blockchain. But Bitcoin is not everything what blockchain is all about. Right? So Bitcoin is just one of the first applications. First application, I would say it as a first movers advantage. That's why when you talk about Bitcoin, everybody thinks it's blockchain. When you talk about blockchain, everyone says, you're talking about Bitcoin. No, that's not true, man. I mean, like, yeah, Bitcoin is a blockchain, but blockchain is like the bigger umbrella, and Bitcoin like comes under it. It's just one small part of it. A lot of things can be done in blockchain, a lot of different stuff. So it's more like, when we talk about cloud computing, everybody thinks, oh, it's just AWS. No, it's not just AWS. You have Microsoft Azure, DigitalOcean, like hundreds of other service providers out there. So exactly same thing, right? So never think Bitcoin, blockchain as a Bitcoin. I would say Bitcoin is a blockchain, but blockchain is not Bitcoin. Blockchain is much bigger than what Bitcoin is.
Sami, we just have one question, I guess, which is when it comes to like blockchain. So this blockchain and the whole idea of the Bitcoin and the cryptocurrency has come actually in the picture recently, like let's say 2 3 years back or something. And what's the actual advantage of any has a business or has a developer now that we're actually having a webinar for developer centric, right? So how do they take the advantage out of it, or how would that help them to get a glance over what is going to come next? Maybe that's a business, maybe as a developer, maybe as a founder, as yourself. So how could you actually use it?
Okay, I think I should take this one, once I've finished a couple of more slides so that people have more understanding about blockchain. But
Yeah, sure.
just to give you a glimpse of it, right? So right now, this
Mhm.
particular industry is going nuts. Blockchain industry is going nuts, right? Everybody
Mhm.
that they have started to understand that blockchain. Okay, so first of all, blockchain is not there to disrupt something. Blockchain is not there to kill someone, or to kill a certain industry or something like that. What I think, blockchain is going to be an integral part or integral component of every business out there, right? Just one of the many components. I'm not going to say that blockchain will be the only component running certain businesses. That's not possible actually, right?
Mhm.
Blockchain will be one integral component. So the core power of blockchain is to provide trustless or peer-to-peer transactions where you do not need any centralized controls. So as a
Mhm.
user, if I'll talk about that later as well, but just to give you a
Mhm.
glimpse, let's
Yeah.
talk about a decentralized finance. In decentralized finance, if I'm into decentralized finance, I'm like one of the founders of decentralized finance protocol out there. So if I'm using those protocols, I am the true owners of my funds. That is not possible in
Mhm.
the traditional finance. The traditional finance, if you have your money with a bank, that bank owns the money, right? And if something goes wrong with that particular bank, your money is stuck over there. That happened with us with one particular bank. I don't remember
Punjab
that particular
National Bank,
bank's
it
name,
is.
right? Not PNB. There was some other bank where they froze the users' funds and you cannot withdraw more than 1,000 or 1,500 INR per day or something happened like 2-3 years back,
Okay.
right? And so yeah, I mean, like you are at the mercy of
Yes.
banks, right? And even if you are in the share markets, right? Those funds or like those shares are actually not owned. Those are and not in your custody. It's with your broker's custody or like whichever platform you are using. So, but in decentralized finance, you are the actual owner of your funds. If I am on Uniswap on certain positions, I am the
Mm.
actual owner. I can do whatever I want to do with it.
Mm.
Right? I'm on QuickSwap. I can do whatever I want to do with it. So that's the
Mm.
true power of blockchain. Blockchain gives you the true ownership of your assets, right? Which in
Mm.
traditional finance world is not possible. It's not there. You think you are the owner of that money, which is sitting in your bank. That's not true. Your bank is the owner, and if that bank wants or if that particular bank goes bankrupt, like government can issue a statement and like freeze your funds. You cannot withdraw more than $2,000 a day, and that's not possible as well because now there is like 100 people standing outside the ATM machine to withdraw that money, right? So you are not the true owners, but in case of blockchain and decentralized finance, you are the true owners, right? So
Yeah.
I'm just like trying to like tell you how like what's the power of blockchain, right? So
Yeah.
this is something which every business is getting now, right? Especially in the financial domain, in the land assets domain, I would say, right? So now they are trying to build these applications or these components into their business as well. You must have heard recently that Facebook is trying to do their NFT programs with Polygon, Meta or Facebook,
Mm.
Instagram. Recently, we did a NFT drop for Dolce and Gabbana, right? Balenciaga, they are going to do their stuff on
Yeah.
blockchain.
Yeah,
Stripe has
exactly. There.
Stripe has integrated blockchain into their platforms. Amazon is looking into it. Google is looking into it, and eBay is like they're planning to do their auctions on blockchain. So all these industries, all these domains, now they are understanding the power of blockchain, the power it provides. So now this basically gives a sudden surge in the demand for blockchain developers out there, right? Because now everybody is trying to integrate these systems now. So these people or these companies, these organizations, they need someone who understands this technology and can implement those components for them. Because now, okay, so one of the problem in this domain is now these people they are like starting to understand that yeah, they need to integrate this technology, but there are very few people who actually understand this technology. Even not these people, I mean, like these big companies that do not understand it properly. So they need
Mm.
someone to tell them, like, okay, so they want to do it, but what to do and how to do it, right? So that's where blockchain architects or blockchain developers come into play, right? So if you
Mm.
want to get into that particular domain, you need to understand what blockchain technology is all about, and you need to learn, like in which particular aspect of blockchain technology you want to work. There are multiple aspects of
Mm.
blockchain technology, right?
Yeah.
So let's talk about it later, I would say.
Yeah, sure.
Okay, cool. So now blockchain has many meanings, right? So again, like this is an analogy which I like through phone and blockchain. I gave you another analogy through physical ledgers, right? I like this one as well, right? So if you talk about phone, like if you think from a higher perspective, so when the phone would have been invented, somebody first would have invented an idea of a phone network where they must have thought, I want to talk to my relative sitting in, let's say, US or UK. I'm not able to do that. I have to write letters, and that letters take, let's say, a month's time to go through ships and something and deliver to them, and then they will write back, and I'll get a response in another month. So the roundabout time is, let's say, 2 months to write to someone and to get a response. How about I develop a system where I can simply talk to them sitting here at my home, and uh, like my relative sitting in his house in UK or US, right? So somebody must have come up with a phone idea or a network specific idea where they can do a long distance communication seamlessly without waiting for hours, days, months, right? So somebody must have thought about that particular idea. They must have written some specifications, technical specifications or stuff. This is how network should work. These technologies should be used. These radio technologies, like whatever technology is used in phone network, I don't know. But somebody must have come up with certain specifications or some kind of guidelines that how this should work. Now there came a specific phone networks like BSNL, Vodafone, Idea, Geo, and everybody implemented that particular idea, but in their own ways, right? Like Geo supports a different technology, but again, that core concept is same, right? Which was 100 years back, right? But they have their own technology. BSNL have their own technology. Vodafone have their own technology, right? So everybody, like on all these like BSNL, Vodafone, all these companies, what they are like specific implementations of the phone network, right? Or the service provider, I would say. So same with the blockchain. The first idea of blockchain came, then somebody did some implementation, right? And the first implementation was done by Satoshi Nakamoto, Bitcoin. Then other implementations came like Ethereum and other stuff, right? Now there's a specific use of phone network, right? So first of all, there was an idea, now there's an implementation, and now there is a use case, right? In case of phone, and the use case is what I can talk to my family at a long distance. I can send them fax. I can send them what else, like SMS, right? I can do video calls and all that stuff in the recent times as well. So similarly in blockchain, the idea of blockchain came, then the specific implementations in form of Bitcoin, Ethereum, and other blockchains, and then that specific use case. And the first use case was money transfers, or like Bitcoin transfers, you could say, or the value transfers. Now there are other financial applications like exchanges, decentralized exchanges being built, lending, borrowing, or money markets being built on top of it, NFT platforms being built, different marketplaces being built, right? So to any technology, there are three phases, I would say. First, the idea; second, the implementation; third, the actual use case, right? Same with blockchain. So again, what is blockchain? A technology that permits transactions to be gathered into blocks and recorded cryptographically, chain blocks into chronological order, allowing resulting ledger to be accessed by different nodes. Again, like it's the same thing as I said. It's a collection of transactions into blocks. Blocks are stitched together. Now they are stitched together. Cryptography. I wasn't talking about cryptography much because I don't know how many people understand cryptography here. But like when I said before that, you cannot simply pull a block out of blockchain and nobody will get to know about it, right? Everybody will get to know about, because they are cryptographically arranged or cryptographically attached with each other. So if you, let's say, if you pick a block from between and try to like put another block in there, the cryptographic signatures will change, right? So by that, everybody will get to know that something has been tampered with, and they will reject your claim simply outrightly. They will say, no, kick this block out, kick this stuff out. This is illegitimate, right? So again, like that is what blockchain is, right? Different definitions of blockchain, but like saying the same thing. Yeah. So this is how centralized system works. You have a bank, you have multiple clients transacting with each other, and they think they are transacting with each other. Client A thinks I'm transacting with client B, but that's not true. You're transacting with bank, and bank is transacting with client B on your behalf, right? You are putting all your trust on this bank. But in case of blockchain, you can see these nodes, right? We call them nodes, or you can call them network participants to understand it better. But when you ever hear about a blockchain, a node in a blockchain system, whenever you talk, somebody says, that I'm running a node or stuff, it's more like I'm participating in that particular blockchain, right? I'm one of the participants of blockchain. In technical term, we call those participants nodes, right? Now, there are no centralized authority who is like managing this blockchain. There are just nodes. They are interacting with each other, validating transactions, validating blocks, talking to each other. That's how the entire system works, right? No centralized authority. So if this node starts doing something wrong, let's assume node A, other nodes will get to know about it, and they will start rejecting his claims, right? Without any centralized, I would say, consensus, right? How does blockchain works? So each transactions occur and the parties agree to its detail. It's encoded into okay. So let's see. This is how it works. Like better than this one, yeah. So this is how it works. Let's assume you want to do a transaction on blockchain. So this is the entire process. So what you will do is you will initiate a transaction. First of all, you will say, I want to transfer 100 Bitcoin to ABC person. With that, you will initiate a transaction, and there's a technical way of doing it. I'm not getting into detail, just trying to like make you understand how it works, the process, how it works. So first, you initiate a transaction, you sign it with your digital identity, right? You need to sign it, right? Like in case of bank, whenever you do an, let's say, a checkbook transfer, you sign on the checkbook, right? Whenever you do an NFT transactions, you do enter your passwords, right? Basically, those password prove that you are the actual person transacting, not someone else from your account. Similarly, in case of blockchain, if you want to transfer something from your account, you need to sign that particular transaction so that others in the network can verify that this transaction is actually coming from you, not someone else, right? So that's where digital signatures come in. You initiate a transaction, you sign the digital signature, you're using your digital signature, right? In case of blockchain, that's where you must have heard about private keys, public keys, addresses, and stuff, right? So in case of blockchains, you have your own addresses. You can generate your address, and every address has a private key. That private key is very important, right? You should not lose that particular private key, or you should not hand it over to someone else. Because if you hand it over to someone else, somebody else gets access to your private key. They can access anything which is there in your account, because now they have the ability to sign transactions using your private key, right? And when they'll send it to the blockchain, blockchain will understand that it is coming from you, because in blockchain world, you are recognized by your public and private key. If somebody else has your private key, that person is you, or like can access all your files. So you should not never lose your private keys. Now, using your private key, you sign a transaction, which is called digital signature. Now you broadcast that transaction along with the signature to the nodes or to the participants of the blockchain. Now those participants will start validating your transactions, will start looking into it. The first validation they'll do whether the signature is okay or not, whether it's actually signed by you or not. They will verify it. Now they'll see what's in there in the transaction, and they'll figure it out. Let's assume you are doing a transfer of bitcoins. Now those uh, nodes will start figuring out whether you actually own the bitcoin or not. If you will own it, they will pull you. Just give me a second. Yeah, so they will pull bitcoin from your account and will send it to the other person's account. Now, most of the nodes will start doing it as soon as you will send the transactions, right? And those nodes will aggregate other transactions as well, not only yours, because now they have to fill a block, right? And in one block, there can be multiple transactions. So now they will do this for multiple transactions, multiple nodes, and they will create a block. Now each such node will create its own block and will publish to the network that I have validated this block. All the transactions within this node, within this block, is validated by me, right? And they'll do a certain work. Okay, we'll get into the work later on, but certain work they do, right? And now that particular blocks or block is sent to the other participants, and now they'll start verifying it, whether that particular block is valid or not, transaction in the blocks are valid or not, digital signatures are valid or not. So that's how the system works. You initiate a transaction, you send it to the blockchain node or multiple nodes. They will like distribute it across all the entire blockchain network. They will start verifying it. They will create blocks, and if everything is okay, that particular block is put, into the blockchain. Any doubts in this stuff? Someone? I'm not able to see the screen. Let me check this.
I think we have two questions in the chat. Can you access this, Samir? You want me to read it? I think Rajesh Kumar is asking.
I can see that. How to develop a blockchain app which can be used for any domain other than financial? Will it require any new programming language? Okay, see, you can like develop any blockchain application. It's not just about finance. You need to think about it first, right? What application you want to build, right? This is not something where you need any developer skill to basically figure out what needs to be built. Once you have figured out what needs to be built apart from financial applications. So first of all, like there are not only financial applications. Like yeah, financial applications have biggest application in the blockchain space as of now. But NFTs are coming up, right? Non-fungible tokens. You can look into what NFTs are, right? Metaverse integration into blockchain is coming up, right? Supply chain stuff is coming up. So a lot of like activities happening apart from financial stuff. Now, will you require a new programming language? Like depends. Like in blockchain development, there are multiple steps into it, right? The first step is multiple phases, I would say, or multiple areas where you can do blockchain development, right? So the first one is the core blockchain development, where you develop the blockchain in itself, like you develop Bitcoin itself, you develop Ethereum blockchain. And the second set of development is where you develop applications on top of the base core platform, right? On Bitcoin, you can write some scripts and stuff, but yeah, I mean, like a lot of application development is not possible on Bitcoin. Let's talk about Ethereum. So if you want to build some application or some dApp, basically in blockchain world, it's called dApp or decentralized application. On top of Ethereum, you need a different set of skills, right? So now you have to decide whether you want to be a core blockchain developer or you want to be a decentralized application developer. Two different stuff. So if you want to be a core blockchain developer, you need to understand how Go programming language works, how C++ works. So in most of the core blockchain applications or core blockchain protocols, Go is used, Golang basically. And now if you want to be a decentralized application developer, which means you need to understand smart contract development. For that, you mostly need to learn Solidity language, right? Because most of the smart contract development work right now in the industry is done in Solidity, right? because most of the work is done in Ethereum, Polygon, BSC, Avalanche, and those all support Solidity, right? If you want to work on another blockchain platforms like Solana, I think for that you need Rust, right? But if you learn, let's say, Golang, Solidity, and Rust, you should be able to cover 99.9% of blockchain development. Second is, how can we get started with blockchain development courses? Are there any university that provide a specific course on blockchain? So there are a lot of blockchain development courses on different platforms out there. Even some universities, I think they have started providing some course on Coursera and stuff. But I would not suggest you to go ahead with that. If you want to learn what blockchain development is, I think there are certain courses on Udemy, right? 14, 15 hours courses. Because I personally have found that Udemy has the best course. Udemy has the most useful or practical blockchain courses out there, apart from any other platforms, right? So you can like take those courses, but then I would like don't spend much time on these courses and stuff. Like they are not much useful. They'll just give you basic information and get you started with. And if you truly want to learn blockchain, you should get into some some projects, or maybe you can do some freelancing stuff, or you can talk to someone and they can give you some real world projects, I would say. That's somewhere you can like truly learn what blockchain development is and like how do you develop stuff on blockchain. Like don't spend much time on courses, like they'll just give you some theoretical information, some project information, but not true blockchain information.
So, like the best blockchain information is something that you can get out of the projects and work you do, not just some courses out there.
That's right. I mean, like you should do some courses to get started, right? That's important. But and for that you can take Udemy courses. I would say Udemy have some best and like short courses on blockchain development. And if when you talk about blockchain development, I mean, like specifically for developers who want to be a smart contract developer, I would say you should like learn more about Ethereum and Ethereum smart contract. You should do courses which are more focused towards Ethereum smart contracts, not Hyperledger and stuff, right? Those are hard to learn. Good starting point is smart contract development on Ethereum. Okay. So what is a transaction? I think it's very easy to understand. It's not something which is specific to a blockchain. Like it's a journal, I would say journal English word transaction. Whenever you do some kind of transfer of value or transfer of information between two entities, it's called a transaction, right? If I am like sending someone, let's say pizza, and that person is sending me, let's say a burger, that's a transaction, right? So it's an exchange of asset between two entities, to understand it in a very layman term, right? So blockchain transaction, from a technical point of view, it contains following information. It contains a lot of other information as well, but mainly this information: sender of the transaction, receiver of the transaction, and the information about the asset which is being exchanged, right? So if it's Bitcoin, it will contain information about like that, yeah, Bitcoin is being transferred, 100 Bitcoin is being transferred and stuff. So some example of transactions are transferring BTC, transferring ownership of land, exchanging pizza for a burger, exchanging what else? INR for USD, USD for INR, like everything is a transaction. Now, what is a block? I think I explained it pretty well. So again, block is nothing. It's a page in that physical ledger, which means it's a collection of transactions, right? In a layman terms, right? So now, again, yeah, hence block is like a page in the ledger. So block only appends in the chain and cannot be modified or removed. As in physical ledger, you cannot modify a page. You cannot remove a page. If you'll do that, somebody will figure it out. Similarly, in blockchain, you cannot modify a block. You cannot remove a block. If you'll do it, other blockchain participants or nodes will figure it out and will kick your block out. Right? Basically, it will not become a part of the blockchain because others will not accept it. Like most of the people will, more than 51% that participants will have to accept something to make it a part of the blockchain, because it's a global stuff, not your personal entity where you can put anything. Like,
so can we modify that? Like, do you have a
if more than 51% people start agreeing that on something, they can do that, right? But that's the power of blockchain, is so much decentralized that to modify something which happened in the past, you need to figure out who are the 51% participants. You have to come to consensus with those participants. You have to make them come on board with you, and then only you will be able to do that, right? That's pretty hard to do. Nobody has been able to do that on big block. It is possible to do that on a small blockchain networks, right? So again, like power of blockchain comes from how big the network is. If blockchain network is small, like it's useless. It's like, I would say it's worse than the traditional system, right? So decentralized systems only work when you have a strong network. If you don't have a strong network, it's better to have a centralized system, because at least in centralized system there is someone to verify stuff. And a small blockchain network, it's pure monopoly, and
Yeah.
like those participants, they can do anything, and there is no entity available to verify what they are doing. So blockchain networks or decentralized systems are only good when the network is strong, powerful, and big, right? That's one of the biggest, like, I would say, prerequisite for a blockchain to be successful. It should have a very big network. Like Bitcoin is successful, why nobody is able to hack Bitcoin? Because it's very big, network
Yeah.
is big. You need enormous amount of power, energy, resources, like everything to change something in the Bitcoin network. And in today's scenario, like today's technological innovations and everything, it's not possible, right?
So how could one build the network that you were talking about in the blockchain? Because blockchain is all about the network. That's the reason like the Bitcoin is big enough that no one could get another Bitcoin like that. So how would one can have that network effect in order to have their blockchain systems or maybe a crypto really wide has or maybe successful as the other?
I mean, see, that's why not a lot of people are building blockchains, right?
Okay.
Everybody is building their applications on top of blockchains, not blockchain in itself. Very few people or very few organizations, and whoever is building it, they need a lot of stuff, a lot of resources, a lot of backing, and like a lot of money to in order to create that network. And a lot of the blockchains out there, I would not name them, but a lot of blockchains out there, their network is pretty, I would say, small, right? 21 validators, 20 validators, those are not true blockchain networks, because those are run just by 21 participants, 20 participants, man. Like those 20 people can come to a, like for a coffee or Starbucks and decide, I want to, you know, just fuck up with this particular network, and they're gone, right? So those are not
Yeah.
true blockchain networks. And a lot of the blockchains right now are in that position where they are not true blockchain networks, right? So, but Bitcoin, Ethereum, Polygon, like the biggest is Bitcoin, I would say. Then Ethereum, that their power of their networking power is very strong. The network is very strong. They are very decentralized and like distributed. Third is, I would say, Polygon, and then others out there. Right?
So not all the businesses can adopt the blockchain technology. Is that what you're saying? Because now that you said that you need a lot of backup for that, including the
No,
networking.
I am not saying that. What I'm saying is, most of the businesses out there, they will adopt blockchain technology, but you don't have to create your own blockchain, man. You need to understand. Okay, so you can still adopt blockchain technology. Most of the adoption of blockchain technology will happen by using blockchain as a base layer and creating your applications on top of that, right? So, to adopt the blockchain technology, you don't need to create your own separate blockchain. Why do you need to create a separate blockchain, right? You can adopt the blockchain technology and build your application on top of that. Like you can use Ethereum, you can use Bitcoin, you can use Polygon, and build your application, your business, or your component on top of that, right? But if you need a blockchain, you need to, okay, so like I said, in blockchain there are two roads to development. One, the core blockchain development, wherein you develop the blockchain in itself. It's a pretty big deal. So to develop a blockchain, you need to understand, you need to first clarify, why do I need a blockchain, right? Because developing a blockchain is a big deal. Now you have to manage a lot of stuff, right? So as a business, as well, you first need to decide what you need to do, and once you have that decision, you can figure out, for to achieve what I need to do. Do I need to develop a entire blockchain, or I just need to develop an application on top of existing blockchain? Right? So most of the businesses out there, they will simply create an application on top of existing blockchains. So that's what even okay. So when Facebook and Meta, they are doing their NFTs and stuff on blockchain, they're not creating their blockchain, right? They are doing it on top of Polygon. When you talk about eBay, they are going to do their auctions on blockchain. So they are not creating their blockchain. They are using Polygon blockchain. Same with Stripe. Stripe has integrated blockchain, what Polygon, I would say, right? So everyone is using blockchain technology, but they are not creating your own blockchain technology. Like I said, right? Let's compare it with a phone example, right? So there are certain implementers out there, BSNL, Geo, and like Vodafone, Idea stuff, right? And a lot of us, like, we are using a lot of these technologies, right? Okay, so let's assume I'm going to build an application. Let's talk about cloud, BPOs, right? Those call centers, I would say, right? These call centers are one of the biggest users of these networks out there, telephone networks, right? But they have not implemented. Now, if you'll say, this particular set of business, they need a telephone network. So are they going to create their own telephone network? No, they will
Hmm.
use,
They
they
will
will use
adopt
the,
it. Yeah.
they will adopt. Exactly. Same with blockchain. So yeah, so Bitcoin and Ethereum, Polygon, they are the implementations. Now, when it comes to the use cases, the third section, you will have to decide which particular blockchain fits your need, and you build your application, your stuff on top of that. That's how it works. Cool. So yeah, so generally block consists of following elements, I would say. Block header, right, where it contains some information about block, version of the software, hash of previous block. As I said, every block is associated with its previous block, right? So the hash, I think most of the people are developers here, so they must understand what hash is. Hash of the previous block. It's a cryptographic proof, or it's a cryptographic, I would say, some kind of computation of the previous block, right? Or a skimmed down version, I would say. Root hash of the Merkle tree, forget about what Merkle tree is. Timestamp when this particular block was created. Difficulty, we'll talk about difficulty. Nonce. Nonce is basically the number of the block. So it starts from 1, and let's assume right now it's 10. So that particular block number or the nonce will be 10. So nonce is block number, right? This is how it looks. This is the nonce. 1000, 1001, 1002. This is the block
Yeah.
hash 001. So it's basically hash of the entire block. You take the entire block, all the transactions, everything in it, and then you create a hash, and that is the hash. Previous block hash, the hash of the previous block. Transaction, like all the transactions in here, you can see, and that their hash. Same with all the blocks. So every block is associated with the previous block, and since every block has its previous block's hash, and this block hash will be calculated using this as well. This will be one of the participants of the block. So now let's assume you change this block. As soon as you will change this block, the hash of this block will change, right? Which means this should change, which means this will change, which means
Hmm.
this will change. So everything, like all kind of like next, subsequent blocks needs to be changed if you are changing this one block. Just one block. If you'll change this one block, all subsequent blocks needs to be changed. And the computing power that you will need to do that will not allow you to do that. So because if let's assume if you change this, by then another block has been created. You change this, another block has been created. You change this, another block has been created. Change this, another block has been created. So you will not be able to basically have so much computing power that you change the entire block, everything. And if you'll just change this and submit it to the blockchain, they will reject it because they will figure out it's not matching this, it's not matching
Yeah.
this, something is wrong, right? So that's how this chain is created. That's why it's called blockchain. Now you can see that it's a block and it's a chain of blocks. It's a chain of blocks. That's why it's blockchain. It's easier to understand. And what block is all about? It's nothing. It's just set of transactions and some information about the previous block and the current block. That's it.
Hmm.
So it's very easy to understand everything if you look from
I
this
think we
perspective.
have a question, Sami, which
Sure.
says, what is the lifetime of any block?
Okay. So the lifetime of a block is the lifetime of a blockchain, right? So if a block has been included in a blockchain, it's forever.
Hmm.
You cannot remove that block. You can still go to the Bitcoin blockchain, or I would say Ethereum blockchain, go to Etherscan, right? And in Etherscan, you can see all the blocks, and go to blocks and you can still see number 1 block out there, or block 0, which is called Genesis block, the first block, right? So the lifetime or a life cycle of a block is whatever the life cycle of a blockchain is. So if a particular blockchain dies at certain moment, or it's like nobody starts using it, or all the nodes they switch off their software and turns off the blockchain, that's the end of blockchain, that's the end of the block, right? Otherwise, like, it's forever, I would say.
I think we have one, not a question, but a query, I guess, Nishpal. Nishpal is asking, we also have whales in Bitcoin. Someday even they can come to consensus. I read it somewhere that it almost happened few years back. Is that what it happened?
I mean, see, whales have a major. So first of all, we need to understand. Okay, who is a whale, right? What this whale means, right? Definitely, like, we all know whales are big, one of the biggest entities in the world right now, biggest mammals, I would say, right? Blue whale is the biggest mammal out there. So when you talk about whale, we are talking about something big, right? If you are like denoting someone as a whale, a person might be a very big. So in blockchain industry, whoever owns a lot of money or a lot of crypto assets, that particular entity is called a whale. So let's assume I own $100 million worth of Bitcoin. I would be considered as a whale. If somebody is owning, let's say, now there are multiple bifurcations of the whale as well. A small whale, like in case of whales, we have blue whale, we have smaller whales, we have mid-sized whales. Same in whale. But anybody who owns a considerable amount of crypto assets, it's considered to be a whale in this particular industry, right? And yeah, whoever asked that question is very right. Right now, whales have a lot of influence, and that's because this industry is still new. So if you'll ask me right now, this industry is not truly decentralized, right? Because still, like, a lot of power sits in the hands of certain people, because this industry is still new. The decentralization, distribution, or the adoption has not happened to the scale that it should have happened, or it will happen in next 5 to 10 years, right? But with each passing year, that distribution is happening, right, from the hands of whales to a lot of people out there. So yeah, right now a lot of whales, they still holds a lot of industry, but not the consensus industry, I would say. They have their role to play in the crypto industry. We can turn down the markets, that we have seen in the recent days as well. Whatever a whales come in, and he decides that I am going to sell $400 million of Bitcoin, right? It will throw the market stuff, right? So whales have that power right now, but not in the consensus industry, not in the core blockchain level, because at core blockchain level, these whales do not work. These whales work at the crypto assets level or at the economic levels. But still, even at the core blockchain level, right now the miners or the nodes who basically does this verification and stuff, they are they are decentralized, but still not that decentralized, to be very honest, right? They are still concentrated and like not that decentralized, because right now to run a Bitcoin node, you need a lot of capital, to be very honest. I mean, like, let's face the reality, right? Technology is still very new. It's very intensive. It's very resource intensive, and a lot of stuff. You need to spend more than $100,000 I would say, or even $200,000 just to set up a effective mining node on Bitcoin. Same on Ethereum. But these technologies are evolving, right? Bitcoin is, sorry, not Bitcoin, but Ethereum is going to move towards proof of stake, where you need lot less resource to run a Bitcoin or Ethereum node or a minor node on Ethereum, right? So that will change the game, right? So next few years, with the advancement of technology, things will change where you do not need much resources. Even you should be able to run your Ethereum or Bitcoin or any blockchain node onto your mobile phone. And that is something which we'll see next 5 to 10 years, right? So if you'll talk about current scenario, yes, it is quite possible. I still would say that it's not possible with Bitcoin and Ethereum, right? Because the entities out there, they do not want to do this, and they should not be able to do this right now. But with other blockchains out there, if their miners collide or collude, they can basically destroy the network. But that changes with every passing month or every 6 months, I would say, because technology is improving. The resources required to run a node is reducing, and even the computing power, the overall computing power is increasing, right? We used to have i3, then we had i5, i7, Xenon processors, and everything. Even now, these iPhones, they have, like, computing power which like 5 years back our laptops didn't have, right? So overall, the computing power or the overall power is increasing, right? And the blockchain technology is moving towards using less power, less resources, right? So that should solve this problem. But yeah, right now we definitely have this problem, and I completely agree that the decentralization that we talk about right now is not there, right? We only are sitting at, let's say, 1% or 2% of the true decentralization that we need to achieve in the future. But again, like, it's a very early stage. You cannot expect a baby to simply start running on day one or on day two, or let's say day 30, right? It needs to grow and learn a lot of stuff. Okay, so let's move forward. Like, these are the important components of blockchain: blockchain ledger, blockchain distribution, and consensus. We already talked about it. Ledger basically is that particular ledger which has blocks as transaction. Distribution is, now, as I said, in blockchain there are multiple participants, right? So there needs to be some kind of distribution mechanism, because these participants are spread across the entire globe. You don't know if somebody is sitting in India, somebody is in US, somebody might be in Antarctica as well, right? So you don't know where all these participants are. So you need some effective distribution mechanism where all the transactions coming to blockchain, all the blocks that are being created, are distributed somehow to everyone, or at least to most of them on time. Important is on time, right? So that is blockchain distribution. So every blockchain has its own distribution protocol, right? Now the consensus mechanism. Now we need a consensus mechanism. As I said, as I said before, in blockchain, if somebody says there is no verification happening, that's false. Verification is still happening, but that verification is not done by a centralized entity. It's done by the entire blockchain or the miners in the blockchain, to be very specific. Whoever is doing a mining activity or whoever is doing a verification activity, right? Now, these miners or these verifiers, blockchain verifiers or nodes, they have to come to a consensus, right? I can say, let's assume I'm a miner. I can say this transaction is valid, this block is valid, but others should agree to it. They should come to a consensus with me, right? So every blockchain has its own consensus protocol as well, right? So these are the three main or important components. Ledger, how do you store transactions and blocks in a blockchain? Distribution, how do you distribute stored transactions and blocks? Consensus, how do you come to a consensus that those transactions and nodes are valid and we should stick it into the blockchain? Now there is a fourth component as well. This was added later on. Bitcoin only had three. This came with Ethereum, the smart contracts, right? And this smart contracts gives us capability to develop applications on top of a blockchain platform, right? So now using these smart contracts, I can write, let's say, a Facebook on Ethereum, right? I can write a token exchange platform on Ethereum. I can write a lending platform on Ethereum. I can write a platform which can store my land records, like anything that you can think about. I can write a messaging protocol on Ethereum, though it will be very expensive. I mean, like, I'm just giving you some, some names out there. Don't try that on Ethereum. It's very expensive to run all this stuff. But yeah, using a smart contract, you can basically do any kind of application on top of blockchain platform, right? With Bitcoin, let's assume there was no Ethereum, no smart contract. If you want to do something, any application, you needed your own blockchain. For every single thing or every small application and component, you need your blockchain. But with the smart contracts power, you don't need your blockchain. You can still use all the security and stuff of Ethereum, and you can develop or your application on top of Ethereum. That's what most of the businesses out there are doing right now. They're creating their own applications on top of existing blockchain platform. They're using the power, security, strength of the existing blockchain and writing their own applications on top of it. That's the beauty of the smart contracts, right? So now consensus, again, like, is the process of reaching to an agreement between parties who don't trust each other, right? So even in blockchain, as I said, I don't know who are the other nodes, right? But I somehow need to reach to a consensus in order to continue the blockchain, to add blocks to it, to add transactions to it, right? So that's what a consensus protocol does in a blockchain. It's a very important component of a blockchain, right? Whenever you hear about proof of work, you must have heard about, like, a lot of people must have heard about proof of work, environmentalists coming and like speaking on television, news media outlets. Bitcoin is consuming a lot of energy. So when they say Bitcoin is consuming a lot of energy, what does that mean, right? What's happening out there? But what is Bitcoin? It's nothing, just a piece of software. So does any piece of software consume so much energy that environmentalists have to talk about it, right? Right now, the amount of energy Bitcoin is consuming, it's like more than 150 countries in the world, right? So what Bitcoin is doing, right? So to consume that much of an amount of energy, that energy is basically consumed in this consensus mechanism. 99.99% of energy that a blockchain network uses goes into this consensus mechanism. Because this consensus mechanism, I feel, is the most important component. Because if something goes wrong in this consensus, something fails, the entire blockchain network fails. Let's assume I have transferred 100 to XYZ person, and if I were able to transfer those 100 to one to like someone else as well, the blockchain network has failed because now I have done a double spend. I have like transferred same 100 Bitcoin to two different entities out there. So the role of consensus mechanism out there, like, is the biggest out there, because this consensus mechanism, this is something which replaces a centralized entity, right? The role, what consensus mechanism is playing out there, that's what bank is playing in the traditional world, right? So this consensus mechanism is replacing all those centralized entities that we needed, right? So yeah, so there are multiple consensus mechanism out there: proof of work, proof of stake, proof of authority, PVFT, like, proof of like DPoS, proof of elect times, POET, and like a lot of stuff. There are a lot of new coming every day, right? But the most important ones that are being used right now, the first is proof of work. It's used by Bitcoin and Ethereum right now, and the second is proof of stake. And Ethereum is going to move to proof of stake. Now, why that? So what is proof of work? We need to understand this, right? This is actually, I feel this is important, right? So why? What happens in proof of work? So let's go back to this. Yeah. Uh, do you see this third block where one or more nodes begin validating each transactions? Node aggregate validated transaction into a block, right? These two steps. This is where consensus starts happening. Now anybody can become a participant in the network, right? Even I can become a participant. I can, let's assume, I can run 1,000 servers on AWS, and I can become a miner. So basically, anybody can become a miner, right? Now, but in case of Bitcoin and Ethereum, the consensus that they use, which is proof of work, you can become a miner. That's fine. You can start doing a transactions. You can start validating transaction. You can start creating block. That's fine. But in order, okay, so there is another thing. So when you become a miner and you do a blockchain mining, you start earning some rewards, right? For do the mining, right? There needs to be some economic incentive for miners to participate. If there is no economic incentive, why should I become a miner? Why should I spend my resources? Why should I put my laptop to work, my AWS to work, right? So there's a reward, and that reward is you get some. In case of Bitcoin, if you successfully mine a block, you get some BTC, right? Which is called block reward. I'm not sure how much it is right now, maybe 3 BTC or something. And same with Ethereum, you have some block reward. I guess 3 or 5 Ethereum per block, which is given to the miner who successfully mines it, right? So there is an economic incentive. So since there's an economic incentive, a lot of people want to do this, right? And this basically brings on board bad miners as well, bad actors as well, right? So to take away those bad actors, these consensus protocols are used, which is called proof of work, proof of stake. So what happens in case of proof of work? Proof of work says, not a problem. You come on board, join our network, and start validating transactions and block. But you have to do one more thing, right? Now, this one more thing basically consumes 99.99% energy. So there is a puzzle which is uh, like broadcasted for every block. Again, this puzzle is decided by the network based on the difficulty. Now you have to solve that puzzle, right? And what that puzzle is, you need to get certain amount of zeros in the beginning, right? And now that's a cryptographic puzzle, right? You need to keep generating some kind of cryptographic hash for a block until and unless you get those number of zeros. That's how it works in Bitcoin, right? Now it's a very computationally intensive, very power consuming task, right, to generate that hash. Because if there are some cryptographers on this call, they'll understand it's pretty hard to get a certain hash. If I'll tell you that you need to get this hash, like, it's pretty hard, right? I mean, like, you won't be able to get it using your conventional laptops and stuff, right? I mean, like, I'll say you need to get, let's say, 5 zeros in the beginning, 6 zeros in the beginning, 7 zeros in the beginning. You need to get this, and then you need to follow this pattern, and you need to compute this hash. You won't be able to do it using your conventional laptops and stuff, right? And same happens on Bitcoin. So that's why if you are a miner, if you are mining it using your laptop, you can mine, but you will not be able to successfully mine because you won't be able to solve that quiz on time. So on blockchain Bitcoin, the block time is 10 minutes, which means you have to solve a puzzle within 10 minutes. Otherwise, someone else will do it, and then it doesn't make if you do it. On Ethereum, that is 15 seconds, right? And similarly, the difficulty is decided as well. So on blockchain networks, specifically Bitcoin and Ethereum proof of work networks, the difficulty of that puzzle, how difficult that puzzle should be, depends on the block time. So if block time, let's say on Bitcoin, is continuously 15 minutes, so the network will reduce the complexity, because network will understand that right now there is not enough computational power to solve a puzzle of this difficulty in 10 minutes. And that network wants that, every block should be there in 10 minutes. So now it will reduce the difficulty so that it is easily solvable by the network participants within 10 minutes, right? Now let's assume there is a puzzle is going on, and for next 5 to 10 blocks, every block was mined in 5 minutes. So network will understand that this puzzle is very easy for the network. It's just taking 5 minutes, and we want it to happen in 10 minutes. Next, increase the difficulty, right? So the difficulty is increased. Now from next time, that puzzle will be solved in 10 minutes. So that's how the entire network, it keeps on monitoring itself, adjust the difficulty of the puzzle, and that puzzle is something which miners will have to solve. So that's why it's pretty hard to set up. You must have heard about mining rigs in Bitcoin, mining rigs in Ethereum, and entire thing is just to solve that puzzle, right? All the energy goes into solving that puzzle, right? So that's what proof of work is. Now, so So that's why it's hard to temper a blockchain. Again, so when you solve a puzzle, you solve that puzzle using the block hash, right? So if something changes in between, in here, let's assume here. So for each of these blocks, right, a lot of computational power has gone, right, has been used to generate that particular hash and stuff, which was required to prove that, yeah, this block is valid. Now let's assume I want to temper this block. I'll change this block. I'm changing this block, but I again need to generate that particular hash, solve this blocks puzzle, right? Now, since I have changed this will change. I have to solve this block puzzle as well, this block puzzle as well, this block puzzle as well, right? And that puzzle is very hard to solve. So no single person or no group of person right now has that much power or computational power so that they can change this, solve the puzzle, change this, solve the puzzle, change this, solve the puzzle, and do it fast enough so that new blocks are not created that fast. Okay, so let's assume new blocks are creating every 10 minutes. Somehow I get the computational power. I'm able to change previous blocks in 5 minutes. So which means 5 minutes this, 5 minutes this, 10 minutes. And in 10 minutes, one block is created. 5 minutes this, 5 minutes this, 10 minutes. Another block is created. Now I'm top of this block. I have changed it and I'm here. So next block I will create. So my block will be taken and all the forging or tempering would be accepted. But if I have that much computational power, but right now nobody has that much computational power to do this. If somehow somebody comes up, let's say tomorrow, and say, I have enough computational power to solve Bitcoin puzzle in 1 minute, they can basically tamper the blockchain. Let's say 100 blocks back, right, and do it. But right now nobody has. That's why in blockchain space, the network of blockchain, the strength of blockchain is very important to prevent this tampering, right? And as blockchain, in case of proof of work, as blockchains become more powerful, the difficulty of puzzle increases, because as more and more computing power comes into the blockchain, this difficulty increases, and as this difficulty increases, it becomes more hard for a certain entity or certain organization or certain group of people to tamper with the blockchain, because now they need more computing power now, because the difficulty has increased. In initial days there was no difficulty because only couple of or 3 or 4 laptops were doing it, right? But it's increasing with each passing day. So that's what proof of work is, and that's why everybody shouts about proof of work, because it takes lot of computing power. Like blockchain right now is like, if you think blockchain is a country, it consumes power. Like I think it's at 53 number or something, or 50 number something, right? Which means like more than 150 countries are behind blockchain when it comes to power consumption on year-to-year basis, right? Just because of proof of work, and that's why Ethereum wants to move away from proof of work to proof of stake, because again, like in case of proof of work, not everybody can become a miner because you need a lot of computational resources to become a successful miner. But in case of proof of stake, that's not true. You can become a miner using even your laptop, and tomorrow let's assume using your phone as well. But that's something you not true with proof of work, right? So that's what proof of stake is, proof of work is, and proof of stake is. Others you can like leave behind. These two are most important, I would say, to understand. Yeah, I think I've already taken. So myths of blockchain. Blockchain is Bitcoin? No. There is another form of database. Blockchain, data on blockchain is secure. No, blockchain is not for data, it's for value, it's for assets, for transactions, not for storing your data. Blockchain is great for storing data. No. Smart contracts are regular real world contracts. Actually, smart contract, it's a misnomer, right? People think it's a contract which are smart enough to execute themselves and stuff and lot of shit. No, I would say it should be, they like should have named something else. Instead of smart contract, they should have said, programmability or application development on blockchain. So it should have been much easier for people to understand. It's not actually smart contracts. It's like ability to write applications on top of blockchain. That's what it is, right? It's not contracts and stuff. So blockchain's only application is cryptocurrency? No. Crypto transactions are anonymous. That's the biggest misnomer. If you think your transactions are anonymous, no, that's not true. If somebody wants to trace it, they can do it. Until and unless you are a very tech savvy person and you do all the required measures to keep yourself anonymous, but 99.99% transactions on the blockchain, they can be traced. Cryptocurrency is only used for criminal activities. That's not true. That used to happen in the past, but not now. Blockchain will change everything. No, that's false. Blockchain is not there to change everything. It's there to evolve things, not change things, right? So evolution is happening here, not changing is like change is not happening. Again, like it's a key characteristics, and this is something which you can find on Google as well. Now there are multiple types of blockchain: permissionless blockchain, permissioned blockchains, right? And open, close, and stuff, right? But most of the use cases of blockchains right now are into permissionless blockchains, not permissioned. Yeah, some use cases are coming up in permissioned as well. So in permissioned blockchains, they are not basically true blockchains, I would say, because in there are certain permissioned entities, which have different roles and stuff. But in case of Ethereum and Bitcoin, everything is open, and there is no permission kind of stuff, right? So let's not talk about permission. I would say, permission again is easy to understand, but first you should learn more about permissionless, because it's easier to understand. Once you understand what blockchain is all about, what permissionless blockchains are, how Ethereum works, then it will be easier for you to understand permissioned ecosystem as well, which is Hyperledger, Fabric, Sawtooth, and like everything. So Hyperledger basically dominates the permission infrastructure. They have multiple set of blockchains out there, but let's not focus on it. Let's focus on the open blockchains first. Right? So anyone can become a member of a public network without any conditions. Each member is at the same access level. There is no access level actually in public blockchains. Public blockchains are mostly decentralized, not completely decentralized as of now because of the reasons I stated before, but yeah, mostly decentralized. Identity-based consensus mechanisms can't be used. That's right. Transactions, each transaction recorded in public and can be seen by anyone. Yeah, this is good as well, this is bad as well, because now businesses cannot. This is good because now everything is transparent, right? So if you want to prove something in the future and it's on the blockchain, it's easily provable. But that's not good for every business out there, because every business doesn't want to have their transactions recorded in the public domain, right? So the most of the businesses are not using public blockchains because of that. But this will be solved by a technology called zero knowledge proofs. I'm not sure how many people know about it. You must have heard about ZK stocks, ZK snarks, ZK rollups and stuff. But that technology is already in development and will be live. I think some part of the technology is already live, but not that usable. But I think in next 6 to 12 months, it will be usable. And that technology will enable to have transactions which are still recorded in public domain, but not with all the information, which makes sense for the businesses, right? So if as a business I want to hide some information and still do a transaction in the public domain, I can do that, right? So this will, again, like this particular technology will enable a lot of businesses to actually start using public blockchains instead of having their own blockchains. Because one of the biggest reasons for a company, for a business to have their own blockchain is to hide their information from their competitors, right? So they cannot basically simply have everything recorded in the public domain. But that ZK technology will solve it. Anybody and everybody can make transactions. That's true. On public blockchain, you can like make any transaction. You don't need any permissions and stuff. Examples are Bitcoin, Ethereum, EOS, Neos, and Polygon, Avalanche, BSC. Private blockchains. Members of the blockchains are chosen as per the admission rules. So every private blockchain have their own implementation and their own rules, right? How do you become a network participant? What do you need to do, right? Each member can be at different access level. Private blockchain tends to be less decentralized. It's actually not decentralized at all, and have one or multiple entities who actually controls the network. Exactly, that's why it's not decentralized. Control lies in the hands of one organization, mostly one, two, three. Like if it's a complete private blockchain, it's one organization. If it's a hybrid blockchain or a consortium-based blockchain, there can be multiple entities. Identity-based consensus mechanisms are mostly used. Yeah, I mean, like all the time, I think it's only identity-based consensus mechanisms that are used in private blockchains nowadays. Private transactions can take place between two entities. Yeah, not everyone can make a transaction. Exactly, you need permissions to make transactions on private blockchains. Examples are Hyperledger, Fabric, Sawtooth, Burrow, and a lot of new blockchains coming under Hyperledger umbrella. Consortium blockchains, like same thing as private blockchains, just that not one entity is involved, multiple entities are involved in consortiums. So use cases. So apart from fintech, there are a lot of other use cases. Supply chain management, government sector, like even Indian government. Like I'm not sure about Indian government, but I have heard Andhra government is doing a lot of their land recording on blockchains. They are using, I guess, Polygon blockchain for that. I think even Uttar Pradesh government is planning for that. Right, entertainment industry. Right, a lot of new music releases and stuff is being launched in the form of NFTs and entertainment industry. A lot of fund gathering or fundraising happening in blockchain and the entertainment industry. Healthcare sector is still very new sector for blockchain. I would say not much is happening in blockchain industry. Asset tokenization, again, like biggest use case, I would say. right? To tokenize all your assets onto blockchain, may it be a land record, may it be a diamond, or like may it be your own picture, right? May it be picture of yourself when you were 1 year old, right? That in itself is an asset. Let's assume you have a 1 year old picture, and you become a Virat Kohli someday, right? So that 1 year old pictures of yours becomes $1 million worth asset, right? So then itself is an asset. So everything and anything which is an asset can be tokenized and can be put on blockchain and can be sold, and can every activity will be recorded in that case, and you can verify every stuff. Fundraising, a lot of fundraising has happened in multiple forms. Initially we have seen ICOs, then we ICOs failed because a lot of scams, spams. Then we have seen IEOs, then we have seen IDOs and IXOs, a lot of stuff. So, but blockchain is a good platform for fundraising as well. Digital identity, energy sector. I mean, like lot of use cases out there. You can think of many more as well. So it's not just fintech. Yeah, I mean, I would say fintech got head start because blockchain actually started with fintech, right? Bitcoin is nothing but a fintech, part of fintech, right? So a lot of fintech, I mean, like stuff is happening on blockchain, but it's not just fintech anymore. A lot of other things are happening, NFTs and this fundraising, digital identity, traceability stuff, real estate. Even people are looking for voting and stuff, land registries and things. Decentralized marketplaces are like one of the biggest use cases. So benefits of blockchain: cheaper, relatively faster, value, ownership transfer. Lot of people say it's not cheaper anymore because Ethereum is very expensive, but that's not true. That's true if you're doing smaller transactions. That's right. It's pretty expensive, but if you like think from a different perspective. So when you make, let's assume, I'm not sure how many people are doing it, but if you are doing ACH transfers, or if you're doing a Swift transfers, let's say from US to India, and you want to transfer 10,000 US dollar, 20,000 US dollar, it takes a couple of days. There are multiple fees involved, right? The first is the intermediary fee, then your bank charges something, right? So yeah, and it takes 2-3 days, even in the current, in the modern world. Let's assume you transfer 20,000 US dollar using Bitcoin. It will take 10 to 20 minutes, at max 1 hour to get six confirmation, because six confirmation is considered temper proof on Bitcoin. Six confirmations, 1 hour, and the fee uh, is much less than what you will pay in Swift, right? So, and assume you are doing $1 million transaction. In Swift, it will charge you a lot to do $1 million transaction, lot of time. On Bitcoin, you do a $1 transaction, or you do $1 million transaction, or $1 billion transaction. Fee is same, whatever the fees at that particular time, depending on the network condition, right? So yeah, if you think from that perspective, it's relatively cheap and it's much faster then, because blockchain came there to solve this problem of financial inclusions, the time taken to do international transactions, to make to money accessible to the bankless people out there, right? And it's a real time settlement. You don't have to wait for the settlement. Once it's done on the blockchain, may it be 10 minutes or 60 minutes, done. Data resilience by minimizing centralized points of failure. Exactly. Improve data auditability and governance. Yeah, data auditability is improved multifold because now everything is transparent, everything is recorded on blockchain, and you cannot tamper with the blockchain. You can still tamper with the physical ledger. How? Let's assume you want to delete an entry. What you will do? Bring a new ledger, make all the entries from start into that ledger, and just remove that. I mean, like, don't make the faulty entry that you want to you know remove or miss out, right? So now you have a new ledger with all set of entries minus the entry that you wanted to remove. So you can still do some kind of tampering with the physical ledger. It was possible if you wanted to do. Yeah, it was a lot of work if there were a lot of pages already which is being filled, but it was possible in physical ledgers. But in blockchain, that's not possible right now. Transparency and immediacy, and the potential for global transaction processing systems. That's what like blockchain is aiming towards, to be a global transaction processing system. So all the transaction or value transfer or assets should be managed by the blockchain. That's the goal of blockchain. So challenges of blockchain. I would say technology in itself is a challenge because it's a very new technology, right? It's early stage technology, nascent technology. Scalability to handle large transaction volume, still not scalable. So if somebody wants to replace Visa using blockchain, that's not possible right now. If all those transactions start coming onto the blockchain, it will crash. Most of the blockchains will crash or will not be able to do that. But yeah, it's changing, right? So 2 years back, it was not able to handle much. Today, it's able to handle thousands of transactions per second, and I think in year or two, it should be able to handle like almost everything. Security issues and private keys shared. This is like one of the biggest issues right now. How do you manage your wallets? How do you manage your private keys and stuff? But again, this is being solved by a lot of companies out there, a lot of products, innovations are happening. So this should be solved pretty fast, I think, in the next 6 to 12 months. Potentially large conversion cost. So conversion cost still very large, I would say, when you want to convert your crypto to fiat, because right now still most of the industry, most of the planet works on fiat, not on crypto. So if you want to buy something, still you need fiat. You don't do that on crypto. That might change in the future because a lot of companies now they are supporting crypto payments as well, right? But you still have to do that, and this crypto market is very volatile right now because still very new. So volatility is very high. So that's why conversion cost sometime is very huge. Enforceability in existing law, that's still very unclear. What are the rules and regulations? Even the governments, the regulators, they don't understand this technology since it's very new. They don't know what to do with it. So like some kind of confusion over there. Still, basically, pushing the adoption behind. Again, like AMC, KYC consideration, same quantum attacks. We still don't know what will happen when quantum attacks will come. But yeah, technologies are being built, encryptions being used, which will basically, counter this quantum attacks. So let's like all these are the challenges, but I think most of these are being already worked upon. So applications of Facebook, sorry, blockchain. So do you think that you own your data over Facebook? Do you think that? No, it's Facebook, right? What if we build a Facebook on blockchain or Twitter on blockchain? So there's a protocol which has recently came up, which is like Lens protocol. They are trying to build social networks on blockchain where, as a user, you will truly own your data because everything is on blockchain managed by smart contracts, right? So even the Lens protocol owner or the person who launched Lens protocol won't have any access, and you can check that through the smart contract. So the biggest benefit of blockchain is you can go to the blockchain or the block explorer and open the smart contract of the application you want to interact with and see what's the logic behind that application, what that application owns and what you own. And you can like transparently see it, that this much part is being owned by you, this much is being owned by application, or 100% is being owned by you or not, right? So whatever application, decentralized application is claiming that this is what we do, you can verify it. That's the power of blockchain, which is not true in case of centralized entities. You cannot ever verify what Facebook is claiming. Just have to, accept their words. So if they say something, you simply have to accept it. You cannot verify it, right? So it's WhatsApp truly peer-to-peer. What about anonymity or transactions? Wouldn't it be better if we can directly contact cab drivers instead of going through Ola or Uber, right? Remove all these aggregators and use blockchain. Wouldn't it be good if government records are more transparent and immutable? Government, like some governments are already trying to do this. So everything can be achieved on blockchain. So this is a task for you guys to think about, and you should think about it. So what do you think can be built on a blockchain? Or rather, I should ask, suppose you have unlimited supply of funds. Let's assume you have like $1 billion or investment, and let's assume you have infinite time, right? So what is that one thing that you would like to build on top of blockchain, right? Like think about it. Don't think about time, funds, technology is available or not, funds available or not, time available or not. First, think about what you want to build on blockchain, right? Then we'll think about whether that can be done right now or that is something which can be done in 6 months from now. But the important thing is to understand the technology and to understand what can be built and what cannot be built. The important part is what can't be built, right? A lot of people think that it's for data, it's for information. Blockchain is not there for data and information, it's for assets, it's for transactions, right? Yeah. So that what are cryptocurrencies like to in a nutshell? Again, you need to think about it, right? It's like, again, like I would say cryptocurrency, it's a misnomer, right? I'm not sure why, like anyone who called it cryptocurrency, why that particular person named it as cryptocurrency. It should have been crypto asset, right? It's not a currency, it's an asset. It's not a currency. Okay, there might be a currency in the future. One of the classes of crypto assets can be cryptocurrencies, but BTC, I don't consider them to be a currency, it's an asset, right? Again, like assets on blockchain are crypto assets, or cryptocurrencies are one of the classes of crypto assets, right? So with blockchain, you can rethink everything. Money, how do you look at money? Organizations, there are decentralized autonomous organizations coming up. Social networks like Lens protocol, trade, like Uniswap, QuickSwap, banks like Aave protocols, contracts, escrow contracts and everything happening on blockchain. So everything can be rethought about when you talk about blockchain, right? So thank you guys. I think that was it from my side. So now, if you have any questions, any doubts, anything, I would be happy to answer it.
I think we answered most of the questions, Samir, but I think one question that we left is Ashish is asking, what is Bitcoin mining?
What is Bitcoin mining?
Yeah.
Okay, cool. So like as I said, mining is way of verifying transactions, putting it into a block, and solving that puzzle. Right. So whenever you hear about mining, it's not only Bitcoin mining, even Ethereum has mining. Right. So mining like is a I would say accumulation of multiple steps. Right. The first step is you collect a transaction, you verify a transaction. Now, second step is you collect multiple transactions, or I would say a set of transactions. You verify those transactions, and you create a block. Second step is you solve that puzzle, right? And the third step is you broadcast that block along with the solution of that puzzle to other miners out there. Now, those miners will verify whether that puzzle has been solved or not. Second, the block created is a good block or not, and the transactions within a block are good transactions or the right transactions, legit transactions. This is what Bitcoin or Ethereum mining is, where you collect set of transactions, you verify them, you put it into a block, you solve that puzzle, and you send it to the miners. And if everybody accepts it, your block and your puzzle, if everybody accepts it, you become a winner for that particular block and you get the mining reward. If somebody else's block is accepted by most of the network participants, then that person becomes a miner, becomes the winner, and that miner gets the reward. This is what Bitcoin mining is or Ethereum mining is, to understand it in a layman's term, nothing else. You just need to verify transactions, put it in block, solve that puzzle, throw it out to others. They'll accept it, you'll get the reward.
I think all the questions are answered, and that was the last question, Samir. Well, that brings us to the end of this wonderful session. I would like to thank each one of you for joining us. Hope you learned something new from today's session. We look forward for your post on LinkedIn along with your key learnings. Don't forget to tag Recro, tag Samir, and tag me on your post, and let us know what's something that you really loved about today's session and what's something that you're taking away from this today's session. Also, thank you so much, Samir, for joining us. It was awesome having you. Thanks for taking out time from your hectic schedule and sharing such insightful information.
Thank you. Thanks, Afsa. Nice to be here.
Before we end this session, we have few announcements to make. So we have created a community for developers called Rebase on Discord. You can join a close community of JavaScript developers if to unleash your true potential. So if you're someone with 1+ year of experience, you can get a chance to connect with fellow developers, get career opportunities. The link to join is in the chat. You can just go quickly and join the Discord and just say hi and connect with the fellow developers and experts in the industry. We also made the LinkedIn post about this session. Do comment your learnings about this post and do tag Sameep and let him know what's something that you'll learn from this today's session. We would be more than happy to look at your learnings and then also answer your queries if you're having any further doubts on the Bitcoin and anything related to that. And I've also dropped Sameep LinkedIn handle in the chat. You can just go ahead and connect with him quickly on the LinkedIn, and he would be more than happy to help you and get you connected personally.
Yeah, definitely.
Yeah. And if you're exploring career opportunities, Recro is hiring passionate developers. Check out the current openings at Recro. You may find something for yourself or someone or something for your friend if you guys are looking for change. And we'll make sure that we would place you in the top leading startups of the country. To stay updated with such more events, you can follow us on social media. You can follow us on Instagram, LinkedIn, and YouTube. You can also follow Sameep on LinkedIn and see what he's up to and what he's actually talking about. Besides, he talks about a lot besides his business and Bitcoin. And if you're having any doubts, queries, you can connect with him personally. You can connect with me if you want to if you want to learn more advanced stage of blockchain, we'll be more than happy to get Sameep again. So that's all for the session, guys. Thank you so much for joining us. Hope to see you in the next session. Take care, stay safe. Thank you so much. Thank you so much, Sameep.
Thank you.